Chapter 12, ANOVA Test. A weatherman has recorded the average temperatures in Portland, Seattle, and Salem in the summer months and believes that they are the same. Run an ANOVA test to determine if the averages are the same using a 0.05 level of significance. The first thing we want to do is state the hypothesis. The null hypothesis is always mu1 equals mu2 equals mu3. The alternative hypothesis is at least one of the means differs from the others. Next, find the critical value and the test value and label it on the graph. The graph is always right-tailed, and we know that there is a 0.05 level of significance. To find the critical value, we go to our calculator and with stats list, inverse F, our area is 0.95. Our numerator degrees of freedom is k minus 1, and k is the number of columns there are. So if we go back to the problem, there's 3 different columns, so k minus 1 is 2. And the denominator degrees of freedom is n minus k, where n is the total amount of data points and k we said was 3. So when we go back to our data, we see that there's 9 points, so 9 minus 3 is 6. When we plug that into our calculator, we get 5.143. We plot that right here on our graph. Next, to find the test value, we go to stats list and enter all of the values in list 1, 2, and 3. And then F6, see ANOVA, and make sure it says data and 3, and then click enter. And that gives you a critical value of 1.553. So if we graph that, you see that 1.553 does not land in the shaded region, which is right here. So that means we do not reject. The next thing we want to do is make a statement. So we say that there is not enough evidence to claim that the average temperatures between the 3 cities are different.